Let's look at another example here. We want to look at the limit as x approaches 0 from the positive side, x times ln of x quantity squared. So the x there is approaching 0. Remember, natural log of x, that graph looks like this. And so as you approach 0 from the right-hand side, it goes down to minus infinity. So the inside's approaching minus infinity gets squared. That's infinity. So 0 times infinity. So we want to bring one of these things down to the denominator. It looks like it'd be a lot messier to bring the log x down. So I'm going to bring that x down as a -1 power. So this is equal to limit x approaches 0 from the plus side. And then we have our ln of x quantity squared up on top. And then in the denominator, x to the -1. So now the top is approaching infinity, and the bottom, this is 1 over x. So 1 over 0, that's approaching infinity. So this is now infinity over infinity. So now we can use the L'Hopital. So differentiate top and bottom separately. So limit x approaches 0 from the plus side. On the top, this is a function to a power. So power comes down in front, times ln of x. And now there's no exponent because we decreased the exponent. And then times the derivative of this inside function. So times 1 over x. And then in the denominator, x to the -1, use the power rule to differentiate that. Negative x to the -2 power. And then we want to try and simplify this and see if it's still in indeterminate form. So this would be a limit x approaches 0 from the plus side. And up top, we've got 2 ln x times 1 over x. And then in the denominator, this negative x to the -2 is -1 over x squared. So we are going to take and multiply by the reciprocal of that. So actually, I can change this. Scoot that down and change this to multiply by reciprocal. So times -x squared over 1. So then this x will cancel one of those. We've got a -x left. So this is the limit. X goes to 0 from the plus side. -2x ln of x. And now this is 0 times infinity again. So we need to bring one of these guys down. In fact, that's just this limit. Just this limit again. But now the power on x is down 1. And there's that constant of -2. So let's see. Let's go ahead and bring the x down. We'll factor the -2 out, which we can do assuming the limit exists. So this will be a -2 limit. X approaches 0 from the plus side. And now this is ln of x over x to the -1. And this is going to negative infinity on the top and infinity on the bottom. So this is minus infinity over infinity. And that's okay. The negative sign, if we brought this negative sign back in, then it would be infinity over infinity. So this is an indeterminate that'll work for L'Hopital. So now let's differentiate top and bottom separate. So this will be limit as x approaches 0 from the plus side. Derivative ln of x is 1 over x. And then derivative of x to the -1, negative x to the -2. And again, this is -1 over x squared. So to divide by that, we're going to multiply by reciprocal. So this will be limit. X approaches 0 from the plus side. We've got a 1 over x. And then times negative x squared over 1. And then I forgot my -2. Should go in here. And then also out in front. Right there. And so now let's see here. Negative and a negative will make a positive. This x cancels one of those. So this is 2 times the limit as x approaches 0 from the plus side of x. And that's just 2 times 0, which is 0. And that should make sense here. Logs grow pretty slow. Well, actually, this goes down fairly fast. So maybe our intuition is not a good measure in this particular example. But L'Hopital does the job.